happen to remember from yesterday where the vertical asymptotes come from.
Directly from the domain.
Directly from the domain. So in other words, in a problem like this, I'm going to look at the denominator, right? Because when domain is considered, there are two things we look at, radicals and denominators. This problem doesn't have a radical, so we are focused on the denominator. All right? What do you think we might want to do with this problem based on what we did yesterday?
Factor by grouping.
Just split it up. So in other words, factor it. So we're going to want to factor this thing. So the top factors, how? How does that top factor? Please be careful. X plus 1.
X minus 6.
You are perfect. Good job. Good job. Those of you that were thinking 2 and 3, be really careful. Not this time, because that's a minus right there. And a minus right there. Okay, so that's perfect. What about the denominator?
By grouping.
We're going to have to group it. So remember how we practiced that in the last chapter? That's why we practiced it, so we can handle these big problems like this. So what can I take out of the bottom?
X squared.
Or I mean the first two, x squared. And that leaves me with x minus 4. Right? Right. What about here now? This is a little tricky. What can I take out there? Negative 1. And that will leave me with x minus 4. Remember, I'm taking out a negative. So there's my common factor, which I write down. And then I have x squared minus 1. What about x squared minus 1?
Factor down to x plus 1, x minus 1.
It is x plus 1, x minus 1. So there is my completely factored problem. Would you agree with me?
Yes.
Okay.
You gotta take out x plus 1 on both sides.
Okay, so it's completely factored, but Pat has noticed that we can cancel. So this actually leaves the problem, and now we're down to this. Now your job is simply to sketch the vertical asymptotes. That's all you're doing. But what did I say yesterday? We were kind of just making a side note of when we canceled, what is going to show up in our picture when we get that far? A hole. So I'm going to make a note over here to the side that there's a hole at the point where x equals what? What do you think? Negative 1. Kids, it's been a constant theme for us. When we either put numbers into parentheses or take them out of parentheses, it's always the opposite. Always. So when I cancel out an x plus 1, that means my hole is happening at negative 1. Now, let's look at the denominator that we have left. Where are the vertical asymptotes going to be? There are going to be 2 of them. One will be at 1. And I'm going to say it one more time. It's the opposite. Right? And where's the other one? 4. So you have on your paper, all you were having to do is graph the vertical asymptotes. There they are.
Wait, so why'd you put negative?
Somebody tell him, how did we know the hole was going to be at negative 1? What canceled out, Logan?
Oh, yeah.
Right? Plus 1 canceled, so that means I'm going to be at negative 1.
Will there be some asymptotes that have 1 line, 2?
You mean there will be some problems that have 1 vertical asymptote, and there'll be other problems that have 2? What does that depend on totally? How many x's you have in your denominator. If you have 2 x's in the denominator, you're going to have 2 asymptotes. Now, what if that hadn't canceled?
You're going to have 3.
Exactly. If that had been like an x plus 7 down there, then I would have 3 vertical asymptotes, right? So yeah, you can have as many vertical asymptotes as you want. Now, polynomial functions, a lot of the functions we've dealt with so far, they don't have any asymptotes. You only run into asymptotes when you put a denominator in your problem, right? That's when you run into asymptotes. Now, the next section is exactly the same, except we've graduated now to doing horizontal and vertical. So let's start with what we know. Does anything factor or cancel in this problem? Wait. There's no canceling or factoring you can do in that problem. Kids, remember, if you don't factor, you don't cancel. Okay? Does it have a denominator though? Yeah. That means it's going to have a vertical asymptote. Where is the vertical asymptote in this problem? X equals -3. That's right there. That's your vertical asymptote. That you already know how to do. That's what we practiced already. Now the horizontals are a little bit trickier. Okay, so pay close attention. And I'm not sure how you're going to note this, how you're going to make notes there about this, but this is what you do. You okay, Marco?
Yeah.
You sure? Okay. Do you have rash like he has, or?
No.
Okay. Okay. All right. In order to find the horizontal asymptote, we look at just the x's in the problem. So I like to draw a circle around them. If that's all we had in the problem was just the x's, so pretend this isn't here. Now would that reduce? What would it reduce to? Y equals 2, right? That is your horizontal asymptote. So you have a horizontal asymptote at y equals 2. Now, two things. We're going to do more examples, so don't panic if that's a little confusing to you, but I want to remind you of two things. We're going to be drawing vertical and horizontal asymptotes. When you draw a vertical line, on your coordinate axis system right here, when you draw a vertical line, what axis does it cross? Isn't this the x-axis too?
Yeah.
When I draw a vertical line, I cross the x-axis. So vertical lines are x equals. When I draw a horizontal line, what axis does it cross? Y. So horizontal lines are y equals. We're not going to get those mixed up. Every time you draw a vertical line, it's x equals, because it crosses the x-axis. Every time you draw a horizontal line, it's y equals, because it crosses the y-axis. Okay? All right. Now we're done. All you had to do was graph your horizontal and vertical. I know that's our first one. Let's look at the next one. Let's see what you can do with this one. Let's do the vertical first, since that's kind of, we've already practiced it. Where do I look when I look for vertical asymptotes?
Denominator.
Denominator. Now, what do you notice about this problem?
They're both factorable.
They're both factorable, right? So I'm going to go ahead and factor everything. We are the difference of squares. So it's x plus 2, x minus 2, x plus 3, x minus 3, right? Something like that. Does anything cancel this time? No. Now all that means is there won't be any holes in this picture. When I get around to graphing it, there won't be any holes in it. But are there asymptotes in it?
Yeah.
Yes. In fact, since there's two parentheses down here in the bottom, there's going to be two vertical asymptotes, right? And what are the equations of those vertical asymptotes? X equals -3 and x equals +3. Vertical asymptotes. Crossing x-axis, x equals. Okay? now, this horizontal is tricky, there's no question about it.
Can I try it?
Well, what do you think?
I think that because there's 2x squareds, they're going to cancel. There's no vertical. There's no horizontal.
There is. Your logic is exactly right, and it's your final conclusion that's wrong. What's x squared over x
Oh, it's
squared?
0, so it's going to be 0.
It's 1. It's 1. So, Brendan, you're thinking exactly the right thing. He says, I'm looking at my x squared over my x squared. When we do horizontal asymptotes, we only look at the highest power of the letter. So in this case, it's x squared and x squared. In this case, it was x and x. What happens when you have x squared over x squared? It makes 1. So your horizontal asymptote is y equals 1. When we start graphing stuff, guys, you are going to have this framework set up, because when you start putting in parts of the graph, these are like your dividing lines. You're going to have 3 separate chunks of graph here because of the way those asymptotes are splitting it up. All right, okay, let's try the next one. What do you think about C? Anybody want to take a guess what you think the vertical and horizontal are for problem C?
Horizontal's going to be 1, vertical's going to be 4.
I heard somebody say something's a +4. What is it +4? So it's a vertical asymptote at x equals 4?
Yes.
Because vertical asymptotes come from the denominator, and it's always the opposite, so x minus 4 gives me a 4. How about my horizontal?
It's be 1.
1. Don't just say 1, say y equals 1, because your horizontal asymptote. And again, kids, look up here. This is where you're looking when you're looking at a horizontal asymptote. You're looking at x over x. That makes 1. Don't look at the rest of it, it's just the x parts. All right, what about D? Yep.
What was that negative sign like in front of the x?
Then it'd be -1. If you had negative x over x, it'd be -1. Yep. All right, what about the next one, guys? What do you think here?
This can't be figured.
Now, let's not panic. What? Not 5. You're thinking the right way, but you're doing the wrong operation. This is 3 over 8. So when I do my horizontal asymptote, I have 3x over 8x. What does that reduce to? That doesn't reduce to 5. That reduces to 3/8,
3.
right? 3/8. So your horizontal asymptote
It's 3/8.
is y equals 3/8. Remember, the 3 and the 8 are coefficients. They're not exponents. They're coefficients. It's like having 2 over 4. You reduce it.
So are you allowed to make a, so it has to be dashed every time, correct?
What?
The line has to be dashed every time?
Yes.
Okay.
When we do our asymptotes, they're dashed lines. Everywhere but on your calculator. Sometimes your calculator it doesn't dash very well. All right. What about my vertical asymptote? Where is it? What did you say, Maddie? You're close. Eight, yeah, 8x plus 6 equals 0. So that would be -6/8, which I will reduce to
-2/3.
-3/4.
3/4.
So my vertical asymptote is at x equals -3/4. Vertical asymptotes are the cannot be's. They come from when the denominator is 0. Now,
Wouldn't it be a positive 3/4?
oh, wait a second. No. You gotta subtract, what is the opposite? It's gonna be the opposite. So move the 6 over, it becomes negative. So no, it's at negative.
Yeah, but you have -3/4.
This came from setting the denominator equals 0. So if you set that equal to 0 and solve, you get negative 3/4. Right?
I think she, like, when you make an equation like that, you don't flip the sign. You don't want to change negative to positive, because it's counterintuitive.
Okay, I'm not following the
Like on
question.
the other problem,
Uh-huh.
it's x, on the bottom it says x minus 4, but the asymptote is x equals 4.
A
So they're
positive
asking
4.
if we switch the sign on
Yeah,
this one.
that's a plus. It became a minus. Yep. Yep. You can think of this as a parentheses. It's not really, but you can think of it as that. Yes. Okay? Now, there should be a thought in your mind, and it's having to do with a problem like this one. Now, first of all, what do you notice about that denominator? It factors. So you can factor that into x plus 2, x minus 2.
Yeah.
Now, is that anything going to cancel in this problem? No. So you're going to have two vertical asymptotes. You're going to have a vertical asymptote at x equals 2 and a vertical asymptote at x equals negative 2. Are you clear on that?
Yes.
Okay. What's a little different about this problem?
X squared on the bottom.
Yeah. If you look back at all of our other problems, I told you to look for the highest power, and they matched. So you had, if you had an x up here, you had an x down here. If you had an x squared up here, you had an x squared down here, right? All the other problems. This one, they don't match. Okay? Okay, you can either memorize the rule, which I'm going to give you in a minute, or you can really logic it out, and it's pretty simple to logic out. The highest power in this problem is x squared, right? And there is one of them in the bottom. There's a 1x squared in the bottom. There is a 0x squared on the top. So when I compare the highest power, which is how I do horizontal asymptotes, I compare the highest power. I have a 0 over a 1. What is 0 over 1? 0. So my horizontal asymptote is at y equals 0. Now,
They're never not diverted.
that will always be the case if in your original problem, the power on the bottom is bigger. Think about it. If you had a problem that was x squared plus 5x over 3x cubed minus 1, what's the highest power in that problem? X cubed, and you have none of them on the top. So what happens when you put 0 over 3? 0. So anytime the power on the bottom is bigger, the horizontal asymptote's going to be at 0. All right, so horizontal asymptote's y equals 0. All right, let's look at the next one. Look at it. What do you think? What are you going to do first? You can. Where is your vertical asymptote going to be?
X equals 1 and x equals 2.
Yeah, so the first thing you did was factor, I hope. Right? And how did you factor it?
X plus 4 times x minus 1.
Okay, guys, you gotta hang in here. This is tough stuff.
It's getting tough.
It's only gonna get harder, so you gotta really pay attention, get the foundation down.
Would you say something been
So
good recently?
Pat said the first thing I'm gonna do is factor the bottom. Hopefully that makes sense to you. That tells me that my vertical asymptotes are where? X equals 1 and x equals -4. Perfect. Verticals are done. Now to get my horizontal, I have to compare my highest powers. What's the highest power here?
X squared.
X squared. I don't have one on the top,
0.
right? So what happens when I say, okay, I got 0x squared over 1x squared? What's 0
Y
over
equals
1?
0. Y equals 0.
Y equals 0.
So we have to make that line still on the 0.
Yes. You have to indicate that's an asymptote. Because when we get around to graphing, that will make a difference. That that's an asymptote there. All right. Let's look at G. You notice anything about G?
X squared is on the top.
Oh yeah. Now the big power's on the top.
Wow, now we're talking.
Now we're talking. This is not good.
Oh, it's not good though.
Y
Now,
equals
I
2.
guess you might think of it as really good. I'll let you decide.
Y equals 2.
Where's the vertical asymptote?
X equals 2.
X equals 2. That's my vertical asymptote. Everybody good with that? Where's that come from?
The bottom.
Denominator, the bottom. All right. What's the highest power in the problem, Sam? Huh? X squared. I do not have any x squareds on the bottom, do I?
1 over 0.
So it's 0 still.
So now I have 1x squared over 0x squared.
So it's 0.
I'm hearing no solution.
No solution.
There is no horizontal asymptote. This crazy thing has what we call a slant asymptote, which we may talk about and we may not. For our purposes right now, no horizontal asymptote. Okay, I want you to just think about this. Those of you that like to just have concrete rules to help you function, when the big power was on the bottom, when the x squared was on the bottom, where did that asymptote end up?
Y equals 0.
Y equals 0. It doesn't matter what the powers are. If the big one's on the bottom, it's going to be y equals 0. Okay? What happens when the big power's on the top?
No, see.
There is no horizontal asymptote. That will happen every time. So you can memorize that if that makes you more comfortable, or you can do what I've been doing, and that is actually putting in the numbers, and you can see 1 over 0 doesn't work. Text?
We have to indicate that there is no.
Yes, you will. Because the question will say, what is the horizontal asymptote? And you'll say,
Proceed to
there
say
isn't
there's
one. Yep. All right, what about this guy? He looks very scary. Anybody have any thoughts about asymptotes?
No horizontal.
There is no horizontal. How did Brendan know that so fast?
The rule.
Yeah, there's no x cubed on the bottom. Can't divide by 0. There's no x cubed, there's a 0x cubed. The big power is on the top.
There's going to be 2 vertical.
Are there?
Yeah, because that can factor.
Okay, how does it factor? You're exactly right. How does it factor?
X plus 2, X minus 2.
X minus 2, X minus 2.
Wait, why?
Yeah.
Oh, because the 4th. Yeah, got it.
You okay with that? Are there 2 vertical asymptotes?
No, because they cancel
Actually,
out.
They're
there's
the same
only
thing.
one.
One,
These are the
X
same
two.
thing. Yeah, this is a little tricky. But if you factor it, you can see that, yeah, there's 2 parentheses. It's a quadratic, x squared. So you would think there would be 2 asymptotes. But since the factors are the same, there's only one. So this last problem has a vertical asymptote at 2. Okay? And no horizontal.
So it's the same thing as the last one.
No horizontal, yeah, yeah. Okay. Now, here's here's what I want you to do. I want you to get out one of the papers that I gave you yesterday, or the day, whatever day I gave you those. And I want you to get out the one. It's gonna be fun. You're gonna love this.
I'm happy about that.
The packet.
Get out your BFF sheet. I gave it to you yesterday. It's a handout from yesterday. We're getting out our BFF sheet. It's a type one. It's got little graphs on it. And I like to think that before we're done, these things are going to be your BFFs. There's 12 of them. And they are going to be your BFFs. But technically, BFF stands for the basic family of functions. But you are going to know these guys inside and out by the time we're done. Okay?
12 of them?
There's 12 of them. So what we're going to do right now is not scary. What we're going to do right now is very simple. I want you to notice that on each one, let's look at the first one. At the very top it says the identity function, that's the name of the function. And then it says y equals. So I'm going to complete the equation for you. And then we're going to draw the picture. That's all we're doing today, okay? Then I'll tell you what you're going to do tonight. All right, so here's what we're doing. Yep. I told you they're your BFFs. You're going to start spending time with them right
These are due
now.
tomorrow?
Just hang loose here a minute. Let's just sort through this. All right, so number one is the identity function. That's the name of it. The equation is y equals x. And the picture, you do not have to plot points. It does not have to be exact. But I want you to have something like this drawn, right through the origin. That is the identity function. Okay? So right now, the words identity function are there. Right next to it, you're going to write y equals x, and then you're going to plot that graph, that shape. Okay? Now the next one is called the squaring function. So its equation is y equals x squared, and its shape is this. These are the basic family of functions. So what you're going to learn is that x squared is associated with this shape. So every time you have an x squared equation, it's going to be some variation of that shape. All right. Then we've got the cubing function. So his equation is y equals x cubed. Imagine that, the cubing function. And his shape, now I want you to be a little careful with this one. It's kind of a squiggly line like that. Please don't make it straight. It's not this. This is the only straight line. This is the cubing function. They have similarity, but they are different. Make sure you're distinguishing between them. All of this is in your book in section 1.3. So if you are confused by anything, you can go back and look. But again, right now, at this moment, we're doing three things. Well, we're doing one thing. We are matching the name with the equation with the picture. All right? So what's next? Next we have the reciprocal function. The equation for the reciprocal function is y equals 1 over x. And the shape of the reciprocal function is this. These, my friends, are asymptotes for the reciprocal function. That is a picture of the reciprocal function. So right now, hopefully, next to the word reciprocal function, you wrote y equals 1 over x, and you are drawing that shape. Doesn't have to be perfect. Nobody's checking that you plotted points exactly right, but that general shape. And so when we go to graph something over something, that will be the baseline shape that happens every time we do those graphs. Okay, now we have the square root function. The equation of the square root function is, of course, y equals the square root of x. And the graph of the square root function is this. Now again, you should have a dot at the origin, and you are curving this out. Don't make it straight. You're curving it out. Don't draw this in, but look up here. If I drew a sideways parabola, it would be the top part of it. It's that kind of a curve. Okay, see how it's curving? Again, nobody's looking for perfection, but you gotta have the general shape right. Okay, the exponential function is y equals e to the x. That's a letter E. It's Euler's constant. You don't need to know that right now. It is a letter E, and it's e to the x.
Can we plug all these into our graphic calculator?
And the shape of this is this. And this is an asymptote. Out here, we're getting closer and closer to it. That is the shape of the exponential. Oh, Mrs. Ford, how am I ever going to remember this? Trust me. We're going to use so much stuff with our BFFs, you are going to know them inside and out. Now we have the logarithmic function. The equation of the natural logarithm function is y equals ln x. If you remember anything from logarithms from last year though, guys, ln x and log x are going to have the same shape. So if you ever wrote y equals log x, I would not mark that wrong, because the logarithmic function is the logarithmic function regardless of this. Okay, what's the shape? Well, it's similar to this one, and kids get them mixed up. The shape of the logarithmic function is this, and this is the 0.10. This is your logarithmic function. Now, do you see how it looks like the square root function? But how is it different? That's what you got to know. How is it different? It goes all the way down, right? The square root function starts at the origin. The logarithmic function goes all the way down. And this is actually an asymptote for the logarithmic function. Oh, Marco's watching the clock.
Come on, Marco.
Backing up. What time is it? Is it time to go?
Well, 1 minute late.
You know what? If I were you people, I would want to stay here so badly. We'll finish this tomorrow. So I'm not giving you anything extra to do tonight. We'll have to do it tomorrow. Because we didn't finish our BFFs.
Period class.